Ladies and gentlemen, please welcome Paul Strong.
Great to be here with my close friends and family. Thank you very much for joining me this afternoon. I'm competing with lunch, which is always a risky business. So thank you for joining us. My name is Paul Strong. What I want to do is spend a bit of time thinking about where the world is going, where software is going, where software-defined is going. It was interesting, the forward-looking statement reminded me that actually the future is basically uncertain, but there's this whole set of things going on which I think are fundamentally interesting and provide a context for us as we think about our journey in terms of our consumption and use of technology. I don't know about you, I'm guessing, are there many car nuts in the audience here today? Yeah, a few of you. So the whole automotive space has become really, really interesting. So cars, I don't know whether you're aware of it, but cars these days are beginning to have somewhere in excess of about 100 electronic control units in them. Individual computers that are being connected, or they're heading towards being connected by Ethernet. Does that sound like your data center? There are a number of cities in the world today where if you get off a plane or you're wandering around and you're in need of transport, and I'm thinking very specifically, for example, in Stuttgart and Munich for sure, where you have your phone, it tells you, and you go along and you find a BMW or a Mercedes, and it lets you into the car, and off you go, and you drive it, and you leave it when you're finished. Anywhere, you dump it, and you move on, and you just had car as a service. All of these cars are getting more and more connected with us. You know, when I think of, getting into a car and using it, I don't want to be configuring anything in that car anymore. Is there any reason why my cell phone shouldn't have the entire configuration of the car, how I like to drive so that it programs the gearbox when I get in? Shouldn't it know my height and weight and size so that it can configure the seats so I'm sitting comfortably, and it knows how I like the mirrors set up so I can have good vision behind me? In fact, yes, we could do all of that stuff. And if you're talking to the car manufacturers, they're starting to think of this world of cars as a service. All this technology that we'll come on to is actually feeding a world where it's very, very different. My generation, when I talked to some of the CIOs of the auto industry, we were obsessed with how fast you can accelerate, how fast you go, and how quickly you stop. And we're beginning to get a little bit obsessed by how many miles per gallon we can do. The assertion is that my children are going to be much more interested in just, I want this kind of car today, I want to pick up or whatever because I'm moving home and pushing some stuff around, or I want a nice soft-top car for the weekend to take my girlfriend or boyfriend out or whatever it is. So this as-a-service thing that we've talked about for cloud is heading off everywhere. And it's going even further than that. There's software-defined decision-making going on, because these cars have vast numbers of sensors in them and actuators that are all computer-controlled. The car makes... some of the more modern cars will figure out based on GPS where in the road you are and which bend is coming up and whether you should be braking, and it'll be doing stuff to your engine management system without you even knowing what is going on. And once, we're beginning to head into this world of autonomous cars. I picked this one only because it's probably one of the prettier ones. But if you look at Google, they're heading down this road too. And there's this software-defined decision-making going on. People are using all these sensors and get aware of the world around them. And so I was fascinated by this and trying to figure out, so what's happening around us that's doing all of this stuff? How do we get to where we are? So when I think about decision-making, as human beings, we kind of take it all for granted. It's pretty simple. You have some ideas, some goals. You make some kind of decision, or you plan, I want to do X. I want to build a car. I want to go around this corner so fast, or whatever it is. You act. You actuate something. Human beings do it, but also today it's motors and things that are connected to technology. There's a set of outcomes. You make some observations of the outcomes and the things, and you close the loop. And we do this without thinking as human beings, but software is beginning to do it for an ever larger set of the things in our life. When you think of the autonomous vehicle, the big and interesting question for these things is, when it has to make a decision, for example, the vehicle recognizes there are two children crossing the road in front of you, and it has a choice to either, the only choice is to avoid them, and to avoid them you kill the passenger in the car, or you kill the two children in front of you. What do you do? So software is beginning to do all of this stuff. So perhaps one of the things we can do is look at the trends and say, how are we getting there in a general sense? I think the automobile and the automotive industry is just one example of where we're heading. We're heading that way in the data center. We talk a lot about the software-defined data center. And it's not just about things being virtualized. It's actually about decision-making and algorithms closing the loop in the things that we do. So I wanted to spend some time really thinking about the sets of technology trends, how they got us to where we are today, and where they're likely to take us in the future, both in the context of the data center and in this notion of software-defined decision-making. For me, there are two very, very profound trends. I'm one of these people who likes simplicity. The world around us is horribly, horribly complicated. But I believe that in general, there are a small number of simple things. And if you understand them, then you can build up that more complicated picture through understanding these basic principles. My background is physics, and we always had a habit of approximating until we got our hands on unfeasibly large numbers of processors where we could simulate everything. We had this wonderful blunt instrument. But there are a couple of really big trends. I think the first one is the evolution of software. This is something you will have heard a lot here at VMworld. We've been moving away from days of my youth when there are monolithic applications on mainframes and mini computers, and even the stuff that you see on proprietary Unix, heading from monolithic through client server, through three-tier, n-tier, to the world we see today of highly distributed and disaggregated applications and services. The observation I would have is the vast majority of our customers' applications and services are actually client server or whatever, because the minute you've created an app, by the way, you've created legacy. 15 minutes after it's first deployed, you now have to figure out how to curate it for the next N number of years and how to retire it and everything else that goes with it. But there's this evolution away from these monolithic to these highly distributed and disaggregated. The second area is the infrastructure that all of that runs on has moved away from, again, being highly centralized, very large machines with a neatly thin piece of networking string between them, if you will, wet string, into this world where your data center is a fabric. In fact, I would argue that that fabric doesn't stop at on the boundaries of your data center. It actually extends out into your mobile devices. It extends out into your cars and your automobiles and pretty much everything else. And what we've seen for 30 years is the constant ebb and flow and movement of functionality and value backwards and forwards across the network. We started with monolithic apps on monolithic machines. We got cheap cycles on the desktop, on the PC, so we put applications there and we empowered people. We got the corporate LAN, so we could share file and print services, and then we could share databases, and then we suddenly found ourselves doing client-server computing. Then we discovered we couldn't manage the darn client, right? Because these end users like doing their own thing. And we had the internet around, and so we ended up with stateless, sort of internet-based workloads and applications and services. And now we find that the client, the device that we have, is so smart. I mean, I think your average phone probably has more computational power than went up in the first space shuttle for sure, because my father-in-law helped design the computer systems on the darn thing. But the amount of power you have in your pocket, or even on my wrist today, is pretty insane. And all we've seen over this 30-year period is the constant movement of that functionality and value backwards and forwards across the network through software. There are a couple of meta trends, if we drill down on each of these a little bit more. The first big trend we've seen in the data center, but again it's beginning to go beyond the data center, is standardization. So when you think about managing infrastructure, applications, and services and everything else, your enemy is diversity. It's not the number of things that you manage or have to look after or whatever. That's not the problem. It's the number of types of things and the rate at which they change. So heterogeneity is your enemy, and homogeneity is your friend. It's not the number of OS instances that's the problem. It's the number of OS vendors and the rate at which the OS changes and requires patching. It's not the number of, it's not the number of terabytes per admin that you have to worry about, because to be quite honest, our friends in the disk manufacturing world will double the density of rust and pump helium into the disks, and it'll all be good. It's the number of LUNs you map and remap on a weekly or regular basis which drives cost and complexity. But what's happening in the data center and elsewhere is that infrastructure is becoming massively homogeneous. x86 is becoming the de facto, and already is actually, I would argue, the de facto platform of choice in the data center, not just for compute. It certainly is for pretty much everything that you see today in terms of new applications and services. But it's also become the de facto platform of choice for storage. The vast majority of the world's data by capacity is in some way directly attached, typically onto x86 servers. In the data centers of Amazon, Facebook, Google, eBay, and pretty much anyone else who are doing large-scale analytics and simulation and everything else that goes on with that. So the data center is becoming much more homogeneous. It's also becoming a de facto platform for the network, which you should have heard elsewhere, when we talk a lot about NSX and everything that's going on with it, is that actually x86 has become good enough for the vast majority of things that you want to do in networking. Not everything. There's some things where you need to forward those packets really, really quickly, but x86 has become good enough. So we're seeing it become this homogeneous layer of infrastructure from a hardware perspective. And it's beginning to stretch out beyond the data center. It's clearly been on the desktops for a long time, but we're beginning to see that push out into the Internet of Things, out into automobiles and everywhere else. People want to be able to have a platform that's essentially homogeneous so they can move their application components backwards and forwards and get flexibility and choice in that sense. The other thing that's fundamentally shifted is obviously this thing. I sometimes joke, working at VMware is like being on Sesame Street. Today's show was brought to you by the letter V. We're going to talk about virtualization until the cows go home. But really, it's magic in many ways. So for many, many years, I worked competing against VMware. I was at Sun, and the thing called Solaris Containers was something that was pretty dear to my heart. But virtualization allows us to do something very interesting. It allows us to separate the applications from the underlying physical infrastructure. This is really the magic, right? Once you separate apps from infrastructure, you can do really interesting things with them. You can move them from one machine to another, from lower capacity to higher capacity, from a breaking machine to a working machine, a machine that needs maintenance to one that doesn't. Once you've encapsulated your application in this wonderful thing called a VM, or even a container, lib container, think Docker, once you've done that, you can push it out into the cloud, you can pull it back in, you get all of these choices, because effectively, you've separated the application from the infrastructure. And this has become so powerful because you multiply it with the effect that your infrastructure has essentially become homogeneous. You now have portability and flexibility as how you move all that functionality backwards and forwards across infrastructure, both inside and outside the data center. For the best part of 15 years, obviously, VMware worked on separating the apps from the underlying compute infrastructure, which is great. You can sit there and you can bring up a VM in 30 seconds up to, I think 7 minutes is one of the worst that I've seen. But it counts as instantaneous for those of us who've been around a long time, because it used to take days or weeks to marshal resources and get new apps and services up. But unfortunately, the network was the problem, because yes, I can spin up the VM, but then I have to do I have to change the policies on the load balancers, the firewalls? Do I need to change IP addresses and everything else that goes with it? And that is why we invested and bought Nicira, obviously, with NSX, allows us to separate the application from the physical network. So again, we encapsulate, in some sense, a virtual network. We create a virtual network that we can manage separately from the physical one. And software does all the decision-making in terms of mapping that virtual network and virtual load balancers and firewalls onto a physical infrastructure. This is very, very powerful because it allows us to scale. And I think this is the biggest thing that we kind of forget. So I don't know, I'm guessing, depending on the size of organizations you're in, some of the smaller ones you may have under management, between 50 and 300 applications perhaps. If we talk to large enterprises today, we see them managing between 3,000 and 5,000 applications. Every application or service has to be architected, integrated, tested again. If it's ERP, tested again. It has to be installed, monitored, managed, archived. You have a business continuity plan. If you're diligent, you'll actually recover your archives to check whether they actually work and they're readable and your insurance policy is valid. So managing applications is very, very hard to scale. And automating the life cycle of those applications is nigh on impossible. But once you put those applications inside a small number of containers, virtual machine or lib container or a virtual network, and you automate those containers, By proxy, you're kind of automating every app you could ever put in those containers. Okay? So all of this stuff with virtualization and homogeneity has allowed us to go to a place, particularly in the data center, where we're now in a position to actually automate the life cycle of applications and services in there. And that's the core of where we got to where we are today as VMware. Once we've separated them, we can automate like crazy. So the software-defined data center really is a very, very simple thing, and I'm not going to dwell on it too long other than to say that many of these principles actually extend beyond the data center, which is kind of interesting. They're going into the software-defined car, and they will end up in other places too. But you virtualize to separate the application from the compute network and storage elements, no matter where they are or what type they are, and then you automate like crazy. And that automation starts life as being very, very simplistic. Think of scheduling algorithms for DRS and things like that, but it ends up becoming genuine, what I would call software-defined decision-making. So what about the applications? They're evolving too. If you think of the traditional canonical stack, we quite often, people think of VMware as an infrastructure company, but infrastructure really doesn't mean anything without the applications that run on it. This is where people derive value, get value from. Our job as an infrastructure organization is to allow our customers to deliver their apps and services flexibly, safely, securely, compliant, and deliver the right SLA, the right throughput, the right performance, and everything else that goes with it. So it's important for us all to understand where applications are going. So when you think about cloud native, for example, this is really, really fundamentally where we're getting to. You need to understand the apps in order to be able to understand where infrastructure has to go to support those apps. So apps have really changed from the world of my youth, I guess, where we had the traditional stack. There was no LTP database. Well, there's always a database beginning with O. There was some kind of business logic. And we got to this point with a stateless client with web-based applications. And the new world has shifted significantly, and we'll drill down onto some of these areas. The first is the client has fundamentally shifted. The client used to be compute to some greater or lesser degree, or just a dumb terminal, but now we're looking at devices that have a vast array of sensors. I mean, your phone has GPS, it might have audio, it might have video, it has accelerometers, you're connected to your watch, which can feel your pulse. There's a whole set of things. I expect you can have wearables today that can already measure your blood oxygen level, okay, non-invasively. There are ways of measuring, I happen to be diabetic, there are ways of measuring my blood glucose and how it's shifting and monitoring. Not accurate enough for telling me how much insulin I need, but accurate enough to know that I'm going up or down quickly. And all of these are going into these kinds of devices. And so these are being connected, and the applications that connect them are becoming fundamentally different, taking advantage of all that information that we're getting from the devices. In the middle tier, we're beginning to see a shift and change around business process mashup, which I'll come back to. Because technology is no longer being used in the way it used to be, which was to, how do I optimize what I've always done? And we're moving to a world where technology is, how do I do things fundamentally differently? And then at the back end, we're seeing real-time streaming analytics, big data, and so forth. And I'll drill down a little bit of those in a minute, because they're fundamentally changing the way we think about doing business and operating and so forth. One of the things that has really happened in the application space is that many things have been turned on their heads. So this is really important from an infrastructure perspective if you're interested in things, for example, like cloud native. In the old days, the way we used to think of how applications ran on infrastructure, if we wanted a reliable application, we built it on more reliable infrastructure. If we wanted highly available, we built it on something that was very, very available or fault tolerant. If we wanted something that scaled, we built it on something that was super scalar. If we wanted something that was secure, we built it on something that was more secure. Well, what's happening right now with infrastructure and software in particular is those assumptions are being turned on their head. We build super scalable applications out of non-scalable components. All the scale-out stuff you see on the web, each of those individual components doesn't scale particularly well, but when you aggregate them, and you load balance and move traffic across them, you get extreme scaling. If you think about availability, each one of those things in a scale-out app is inherently just as reliable as, well, it's just one thing, right? But the trouble is, the thing is that when you have 20 or 30 of them, then you don't mind if you lose one out of that 20 or 30, right? You have resilience in your application and service. So for example, a previous company I worked with scale-out applications, where I was, we scaled out a database index across, we had the biggest machines money could buy in about 2000. and the memory wasn't large enough to scale the database index. So we actually started doing unnatural acts, if you will, with the database. And we separated the index out, and we scaled it across the memory of 64 computers. And then we replicated each of those 64 machines. And so what we ended up with is if we lost a machine, we lost 1/20th of 1/64th of the index. And there were already 19 other copies of that slice of the index that were still available. So the service, unless you lost the complete data center or set of data centers if you were running active-active, was basically 100% available, more or less. And that was built out of essentially unreliable components, the same as RAID. Yeah? Disks are inherently unreliable. You use a layer of software or some hardware. You embed the software in the hardware, who cares? But you end up with storage that is reliable, built out of unreliable. We're also seeing things turned on their head as we think about security models. People used to think about a wall and a moat. How do you keep someone out? I would argue that's as antiquated as, moats and castles in the traditional world of warfare. The mechanized warfare of the 20th century taught us that agility was much more important than fine-grained defensive capabilities. It was about being mobile and hard to catch. Each fine-grained component had a level of security or safety built into it, if you think about tanks. But that's the world we have to move to with security, too. If you're running applications on the cloud and they're being consumed on all these mobile devices, then you really don't know what's underneath you at either end. Yet you have to build secure interactions and secure endpoints on infrastructure that may not be inherently insecure. You assume it's robust and always there, but you can't make any assumptions about the level of security. So this is the stuff we're seeing, fundamental shifts and changes here around the assumptions that we have. And that changes how we think about infrastructure. So when you saw Kit yesterday, when we're talking about the photon stack and the traditional stack, it's because certain classes of applications in this new world have gone off with a different set of assumptions, and they don't need some of the things that we have in the traditional stack. But the truth is, in my experience, is pretty much all applications, and we talked about hybrid, I would say as an architect, they're all composites. There are parts of them that are stateful and traditional, and there are parts of them that are scale out and non-traditional, and people will be combining all of these elements, and so they need an infrastructure that will support both. But it's fundamentally important as practitioners or owners of infrastructure to understand that the working assumptions have fundamentally shifted and changed. And that brings us to this cloud thing, because I would argue the shifts in the underlying infrastructure and the separation of applications from infrastructure, and the fact that those applications are designed in a different paradigm has resulted in this cloud thing. Now, when I mention cloud, I can't see you very well because it's very bright up here, but my expectation is that your eyes are probably rolling at this point and saying, oh, we're going to talk about this cloud thing again, oh no. And I remember the first time I was asked to speak about it, which was about 8 or 9 years ago, so I guess we're no longer in the trough of disillusionment, we're probably somewhere on the plateau of productivity or something. I felt the same way. I'd been doing grid, I'd been doing a bunch of things there. But in all of that time, when I first stood on stage and I talked about this at a conference here in San Francisco, I made an assertion to about 8,000 people that cloud kind of felt like outsourcing 2.0. From a technology perspective, I didn't really understand what the step function was because the stuff had been evolving for a while. Virtualization, separating apps from infrastructure, separating them from the operating systems from infrastructure so we could do interesting things around mobility and consolidation and all that good stuff and rapid provisioning. So I could see how all the technology enabled us to do it. I said, why is cloud this amazing disruptive thing, right? Really, what is the deal? And the thing is, it's actually nothing to do with the technology. Our biggest mistake as a community of technologists is we look at it and we say, we virtualize this, we do this, we do this, we do this, and platform software and infrastructure as a service are compelling because they're cool architectures, and we go to NIST and you look at the definitions of them and you talk about cloud brokers and everything else, and we miss the point. And the point is really that this is what cloud is about. It's about a consumption model and a set of experiences. And this is what we believe is really driving cloud. When you think about it, it's very, very simple. Cloud is all about self-service, instantly provisioned, pay for what you use, cost efficient, and ultimately elastic IT. Something we never ever had before, because what we did in the past, right? We bought software, we bought the hardware to run it on, and then we bought the people who would run the software on the hardware and maintain it and support it and everything else that goes with it. But really what it's all about is that experience, right? It's not about platform software infrastructure as a service. It's about a consumption model. And this thing has changed things, I would argue, in 4 clear dimensions. The first is cloud now allows you to get rid of the services that don't differentiate, the applications and services that don't differentiate your business, and to focus on the ones that do. So for example, at VMware, we consume somewhere in the region of, say, 100 SaaS applications, healthcare, payroll, HR, all of these things that don't differentiate us, right? We don't want to hire the people to architect, install, monitor, manage, archive, and everything else, all of those applications, because they don't make us better than our competitors. We want to spend all our time and money building better applications and services for our customers and better products and solutions. That's what we're about as a business. So cloud allows organizations to focus on their core differentiating value. The second really big thing is cloud unleashes innovation, which I'll talk about as well, because really there's no barrier to entry to the provisioning and consumption of technology anymore. Pay with a credit card, point with a mouse. The third area is the mere existence of cloud providers has fundamentally changed the conversation between lines of business and IT. And that, I can go and get a petabyte of storage with a mouse click and a credit card number. I now expect that from my internal organization. And that's what private cloud is all about. Private cloud is not really about, it has to be written this way. It's about providing this experience. Yes, we'll sell you the technology and a set of solutions that will allow you to deliver this, but it's about this experience. So some of the things, I wanted to explore a little bit more about some of the things that come out of cloud and get us towards this place that I talked about as software-defined decision-making. So one of the things that's interesting about cloud from my perspective when you think of it from a business model is the software is ironically kind of loosely coupled that we build in this model for the cloud. But cloud starts moving us to a world of shared risk between provider and consumer of those technologies. So if you think about it, one of the great attractions is it's all about pay-as-you-go. That means that if you do pay-as-you-go consumption and your business fails, you haven't committed to a vast amount of capital, you've got no friction to doing stuff, you can just rent it and get going. But if you're stupidly successful, there's an enormous upside for the provider, which the provider never had in the past, right? You'd sell a license or an ELA and there'd be maintenance payments, but it's different. Your cost was kind of capped, but now the provider and the consumer actually share in the risk of the endeavor of the enterprise or the business. I would argue that's kind of interesting. That takes us to a place where providers should actually care a bit more and are more vested in the outcome, directly vested in the outcome with their customers, because there's a direct linkage there. And then what we see with cloud is it fundamentally disrupts things. It really puts us into a place where it democratizes innovation and business. I've talked a bit about technology, but in business, cloud has fundamentally shifted and changed things. You can imagine, the joy of cloud. You can be sat there, you could have a good idea. You could go online and register yourself as a Delaware-based corporation. You could get all your back office applications as SaaS. You could get physical goods manufactured in China that you then sell on Amazon or Google or eBay, and you drop ship via FedEx, UPS, and DHL. And you haven't left your sofa. What we see here is in the same way the internet provided organizations with global access to markets to sell goods and services, the cloud is providing organizations with global access to IT resources from which they can build businesses with little to zero friction. And this is really profound, because what it really means for the vast majority of us is that our competition can come from anywhere with pretty much no barrier to entry to the marketplace, other than intimacy, which I'll come back to in a minute. There's an inherent asymmetry. The small and nimble now have access to the same resources as the large leviathans who have everything to lose. This is very, very profound. Right? It truly means that if you're sat on that sofa somewhere and you have a great idea, you don't have to get all this working capital and everything else to go away and make your idea real and to challenge someone's business model. You can just go out there and use your credit card, click on a mouse. I guess that's almost a pun visually. And you can get your resources. And you can go and start a business and you've got what you need. No capital expenditure required. What it allows you to do is to fundamentally change businesses. Because once technology is essentially free in terms of no barrier to accessing it. Yes, you have to pay for it, but pay-as-you-go is very different to that big upfront barrier. Once it's free, people can use technology to basically attack the underlying assumptions that people have in their business models. And this is where cloud is truly profound. What it's allowing people to do, and this is what you see with Uber and Netflix that I'll talk about, and Airbnb, is what they do is they sit there and they look at a business, and someone has a bright idea and say, what are the fundamental assumptions that this business is based on, right? Every business has some base underlying assumptions. And they use technology to go away and basically take away one of those foundation blocks, one of those assumptions, and then the whole house just comes down. And you get to start off all over again. A classic case in point. Anyone remember these guys? I hope there's no one in the room from them. I hope I'm not insulting anyone. But in the early noughties, these guys, that's just over 10 years ago, they were growing 15% year on year. Pretty good, right? Then these guys ate their lunch. No late fees, just stack up the set of DVDs and Blu-rays you'd like to watch as movies, and away you go. Now, the thing that amazes me about Netflix, and I don't know whether any of you are monitoring the news today, but it continues to amaze me because they made an interesting decision today as well, is that they saw what was coming on the horizon. So before iTunes, they offered streaming and shipping and delivery as all part of the same cost as they're offering, right? You paid one fee, you got both. But they recognized the writing on the wall with iTunes, and they chose to eat their own lunch before someone could eat it for them. They bifurcated their own model and allowed the streaming business to destroy, essentially, the physical goods logistics business. Why were they able to do this? One, a great deal of corporate courage. Two, a vast amount of data that allowed them to know what was going on, right? And in fact, they transformed their business, because not only did they sit there and they got out of the delivery business, effectively, in the logistics business, but because they're essentially a digital enterprise, they knew who was watching what, when, where, how, and on what device. And so they actually went and moved from a distributor, essentially, of media to a creator. And they created their own television series, House of Cards, which some of you, no doubt, will remember. Right? And because they knew who watched what, where, when, and how, and when, and on what device, they recognized the vast majority of people who like to watch serials actually like to watch them as marathons. I do that on an aeroplane. It's about the only time I get to watch anything. But a very large number of people do. So they released House of Cards all in one go, all the episodes. Just like that. And they differentiated themselves because they had all of that customer intimacy. Well, I don't know whether did anyone see the reports today? What they announced today is they actually stopped renewing some of their licenses with the film studios, one in particular that has hundreds of titles that are relatively popular, because they seem to have made a decision that there is far greater value in the creation of original content than in redistribution of movies that have already been watched in the cinema. And so they're actually no longer renewing, at least they didn't renew one of their licenses for a very large production studio, movie studio. And this has to be based on the fact that as a company, Netflix has spent all their time getting extremely intimate with their customers, understanding them, understanding how their product is used, and so they have the data to allow them to make this really, really smart decision. This is the world we're going to. It's a different kind of world. There's two things going on here. If you think about the apps and services, I talked about cloud, and cloud allows you to focus away from the applications that don't differentiate you. What do you do with the apps and services that don't differentiate? You actually want to make them someone else's problem. The goal there, all you want to do is minimize customization and get rid of them. Acquire them as SaaS. If you can't acquire them as SaaS, which many people can't because you want to have the data, you may need to own the data, it's regulated or whatever, then you'll put it on a private cloud internally on infrastructure as a service. But you want to minimally customize it, you want to get rid of as much as you can, right? You want to just make it boring and simple and make it go away and cut the price. For the IT that differentiates, and this is what it's always interesting for IT practitioners, is you actually don't want to be just owning the apps that don't differentiate. You want to own the new applications and services, because really this is about driving the top line of the business as opposed to saving money on the bottom line. So all these new applications and services, people are very willing to spend money and invest in because it's all about driving new revenue. And the question is, how do you know how to differentiate and drive all of this new revenue? Well, I think what we're seeing now is a movement away from a focus that we had as an industry for a very long time on systems of record. It was all about the transaction, a whole bunch of stuff and records about people and things like that. But we're moving away now, really. You've heard a lot of talk about systems of intimacy, where it's really engaging, or systems of engagement, where we're engaging with people with mobile devices. All the interactions are digital. And so because we have all those interactions and that they are digital, we can capture a vast amount of telemetry and get an understanding of what's going on around us. But I think we're entering a new phase, and we're really thinking about systems of intimacy. So if you think about systems of engagement, I tend to think of those as being, mobile plus cloud plus social, i.e. people, and big data. And when you munge all of those things together, you get the ability to engage and interact in a way that you never could do with all of these people and customers and partners and so forth. What we see with systems of intimacy in some sense, it's about the Internet of Things, including mobile, plus cloud, plus social in a different way, because it's all about the relationships, not just between people, but between software and machines and all of their interactions, and the intersection of there with big data. And with systems of intimacy, we're able to do new and interesting things. And yeah, the Internet of Things suddenly allows us to be connected to everything. It's pretty scary. And the numbers of the amount of data we expect to have over the next few years that are being generated by all of these sensors is quite obscene. It's in the kind of zettabytes and zettabytes of the darn stuff. We already see in large data centers of the web providers that they have, multiple exabytes of data. And in this world, by the way, where intimacy is everything, you need to be connected digitally with everything around you. It's not just with people. It's with devices. It's with cars. It's with medical devices. It's everything. Everything is connected. Everything has sensors. I was talking to one of the customers that I sponsor. They're a construction company. They actually have sensors that are designed to be powered for 60 years that are built into the steel joists that go into buildings. So for 60 years, they're able to tell you the stress and the shears on the thing all the way through. So the newer buildings that you go in have telemetry in them. They're not just a bit of concrete and steel. There are sensors all over them. A modern data center has 10,000, 100,000 points measuring temperature, airflow, and everything else that goes with it. Everything is massively, massively connected. And as I said, the relationships, it's all about understanding the relationships. Not only do you want to know all of these things and get these data points, you need to know and understand how they're all related to each other. I sometimes say it's like the whole Dr. Ruch thing. Yeah? It's all about the relationships. You want to know, in distributed systems and the things we're building today, the value isn't in the individual discrete things. It's in how we connect them all together. So understanding that is absolutely critical. And that takes us to a place where you get to kind of the Netflix place, or where I was in a previous life, if you're in e-commerce or whatever. It all becomes it's all about having the ability to have fine-grained interaction, to have an infinitely personalized interaction in real time with a person or a device or a thing, whilst knowing the broad context of what's going on around you. So in e-commerce, right, you want to know and understand what products are being consumed en masse, which things are very, very popular, the rates at which they're being bought. You want to know how you can ship them around your infrastructure. But then you want to make sure that the person at the end, you know exactly what they like. You target them with Google with the advertising, but you want to be able to personalize everything to the nth degree for both convenience for you as a consumer and for productivity and efficiency from the perspective of the provider. And so these systems of intimacy, which I think is where we're ending up with, it's intimacy with the past, intimacy with the present, and intimacy with the future. In the past, you tend to think of data warehousing. The present, it's real-time streaming analytics. And the future, it's simulation. Okay, cloud is all about this ability to differentiate. How do you differentiate? You differentiate through intimacy. How do you gain intimacy? It's all through digital interaction. And when you have that, you can build models. That's the amazing thing about simulation. You're predicting the future, and you're differentiating yourself with intimacy with the future. So back to the automobile example I was working with at the beginning. You know, if I'm a car manufacturer, or an auto manufacturer, as you would perhaps say, and my product is differentiated through safety, then you know what I'm probably going to do? I'm probably going to have the best people to write safety algorithms or car crash algorithms around, and I'm probably going to run more algorithms, test crashes, than I would, you know, anyone else. Because 15 years ago, it was a case of, can I simulate a car crash? 5 years ago, do I need to crash cars anymore? It's kind of expensive. Now it's how many iterations of the algorithm do you run to get the safest car? We can simulate everything. We don't need perfect prediction with algorithm. We can just blunt force trauma to knock the problem into touch. So simulation allows us to get intimacy with the future. So when we tie all of this together, you know, when we thought about decision making, you have ideas and goals, you decide and plan. At some point you have to act. You're going to act on things via actuators or whatever. There's some outcomes, there's a set of observations, and you're sitting there going, and you can reconcile all of those, say, I did this, what happened, and then round and round you go to optimize or to do things differently, continue to feed in new ideas or whatever. When we think about simulation, we're doing the same, but it's in the virtual world. So there's a kind of resonance personally when I think about it, because it is virtualization a different thing, because instead of acting on real things, we're doing a what if. We have a model, we act on the model, we're interacting with virtual things that feel like physical things or whatever, and then there's some predictions that come out because that's the outcome. We make observations about the predictions and reconcile them with what we know of the real world, and we go back and we may refine the model as well as run it again to get more refined and better predictions each time. This is the kind of decision making that's moving away from just the physical things and the simple things. This is decision making that is becoming closed loop. And then when you start bringing it all together, it may not be that legible from where you are, we're really seeing that decision making, the decide, goes down to simulation and then wraps round. You sit there and say, what do I need to do? Let's do a whole bunch of what ifs. So I'm acting on the virtual thing, go act on the virtual thing, figure out what the predictions are, eventually refine it, come back, and then make a real decision. Then you only have to act once. Because you can iterate in the virtual domain with your software-defined decision-making much, much quicker than you ever could in the physical domain. Think about those car crashes, for example. How many different versions of a car would you have to physically build to go away and find the one that was actually both the best compromise of design and safety? The answer is, it's uneconomical. But once it's all in software, and it's a software-defined car, as in a virtual car, now I can sit there and I can do all of these things to it and figure out what it's going to do in a crash and make my car the safest without crashing a single car until I get to the end point and I finalize my design. It's funny because there's so many things you can do in this domain, by the way, but one of the few things that's really hard to do is actually, for example, decide which color car you like, because you actually have to see them in the flesh, interestingly enough, because we don't have a good way of rendering them yet. Anyway, so it closes the loop, we simulate, we act, we get observations back which do two things. One, they allow us to go through the loop again around decision making and figure out what we want to do, but they also allow us to refine the simulation and the algorithm and make it more accurate. So this is happening everywhere, right? If we think about what happens in this loop, we do it inside our software. You know, schedulers do it, but they do it based on very, very simple algorithms, things like that. But as we start moving to things like dynamic resource scheduling or sharing in, for example, our clusters, then how you move things across clouds, then we're starting to get into that domain again where there's decision making. You know, in the past, what we would used to do is we would close the loop. And it was expensive making guesses. So on mainframes, for example, 15 years ago with Workload Manager, what did we do? We didn't actually predict how much resource was needed to be taken from person A or job A to job B. We would sit there and take a standard unit and we'd donate it and see how it went, and 30 seconds later we'd do something else, right? And we'd try it again and see what the outcome was in the real world. Now, with the cost of cycles being relatively reasonable, we can actually do simulations and guesses and get those guesses better before we take any actions. So we avoid the pitfalls of the wrong action. So if we go back to the car, the reason I use this, there's a set of spaces where this software-defined decision-making that's already happening inside the data center is entering our real lives. Almost all of us. I mean, how many of you have a Nest? It's already doing it, right? Most of your cars have telemetry up the yin-yang. As I said, somewhere in the region of, we're seeing up to 100 plus electronic control units in a car. They're rapidly heading towards, they don't want diversity either. They would rather use industry standards, so they may well end up with Intel and Ethernet inside the automobile. There's actually a session on the software-defined car, by the way, tomorrow. I think Matthias Schorer is giving it, so I can heartily recommend you go, and he'll give details about what he's seeing in the automobile industry specifically. But the question is, how far does this go with this software-defined decision-making, right? We're letting the software do stuff that's fairly mundane and interesting. The challenge comes when you have those moments and you figure out, so, autonomous vehicle, children crossing road, ravine to the side, what does the car do? We still need human beings for a bunch of these kinds of decisions. But the software is doing more and more of this stuff in a closed-loop way. And the reason it's able to do it is because of these systems of intimacy. Because we are able to take so much data from the past, get it through things like the Internet of Things, all these sensors allow us to know and understand so much of what is going on, that because cycles from things like cloud and elsewhere have become so cheap, we can do simulations to predict the future and be intimate with the future, that now we can make really good decisions and guesses, and this kind of stuff can happen. It's the stuff of science fiction. I don't know, I'm sure some of you are familiar with Isaac Asimov. Some of you may have been fans of his writing. And when I think of the Foundation trilogy, for example, he postulated a kind of pseudoscience called psychohistory, where it was all about predicting the future based on mass behavior in the past. And strangely enough, we're doing that today. It's called big data. It's called real-time streaming analytics. Science fiction has become truth, and the autonomous car is actually not that far away. It'll make most of the decisions for you, but there are some that software still can't make because software isn't yet conscious and can't understand ethics. We plug in the policies that define ethics today. So I've rambled on a bit, talked a lot about where this stuff's going. I think, for me, this is one of the bigger trends that I've seen over the last 12 months. I spent a lot of time talking to our customers about cloud, about software-defined data centers, and about how cloud as a business model has been so disruptive. The risk for most of our customers is we sit there and we focus on the infrastructure and lose sight of the apps and services that infrastructure enables, and lose sight that those apps and services have the opportunity to differentiate business and disrupt business models. We need to understand infrastructure and the applications and how they do that. And what we're seeing now, what I'm beginning to see, certainly, I think we're on our third wave of IoT hyperbole, perhaps. But my gut sense, in the interactions with most of the customers I have, is this is becoming very real this time around. We see a vast amount, not just of talk, but investment, of creation of these systems of intimacy, where people know and understand to the nth order of magnitude what is going on, and they're tying that back into the way they do business. And there is a substantial effort to pull that together in the form of software-defined decision-making, having algorithms and data make decisions automatically because it's just too complicated for human beings to do. VMware's role in all of this, at the end of the day, we talk about one cloud. The reason I think one cloud is more interesting is not specifically that I think someone went away with the idea that we're talking one cloud to rule them all and in the darkness bind them. And that's not what we mean. What we mean is one operational model. We believe our customers want one way of managing their applications, irrespective of which cloud they sit on and where it sits, public or private. Remember I said diversity is the enemy? You don't want 25 different ways of managing an application, depending on who your cloud provider is, internal or external. That's not what it's about. You really want one way of doing things. And for us, it's about that, and it's about being able to manage any and all classes of application. So from VMware's perspective, this is why we continue to invest in things like big data extensions, because we want all those applications. We are, you look at the x86 platform, and the fact we virtualized it, and virtualizing it allows us to be both efficient and agile, and we want to apply all of those capabilities to all of those other applications or parts of systems of intimacy. So big data, grid. Yesterday, one of my colleagues in the office of the CTO gave a presentation on high-performance computing, and how our technology actually enables our customers to be very successful in deploying clusters, grids, and simulators much, much quicker as well as more effectively. And so it's about capturing all the apps and allowing them to be consumed on any device, obviously. And for me, it is all about the apps. I think should have resonated. They were dancing on stage yesterday, and they're wandering around the corridors for those of you who want to have selfies with them. But ultimately, it's about those applications that enable businesses to differentiate themselves and to participate in this world. And our job as a software-defined data center is to provide the infrastructure upon which they run, separate the apps from the infrastructure, then automate the management of those apps and services. There's going to be software-defined decision-making in how we do that. It's already there at a basic level, but it become richer and better through time. The long-term vision has to be that the vast majority of our customers will truly never care about physical infrastructure in the long run. Unless you're a nerd or a geek like me, you probably don't care on the number of cores and threads that your iPhone or your Android device can support, the amount of memory. Most people care about the number of videos, songs, applications, and movies they can have on there, and the number of apps. We cannot afford to be worrying about the details on infrastructure as we go forward, because the world is moving inexorably to a space where all that value, all the work is really going into those applications and decision-making and pulling the data together. And our job is to hide it, to provide you a choice of where you run it on and off-prem, on in your software-defined data centers, on VMware's software-defined data centers, or our service provider partners, and to be able to consume them anytime, any place on the device of your choice. So with that, thank you very much for joining me. I know I was in competition with lunch, and you stayed awake as far as I can tell, so I've done reasonably well. Thank you very much. I'll be walking around later, and you're welcome to come up and ask questions. Thanks.